The solutions on page 155 are all based on the implicit differentiation process, where y is not explicitly defined in terms of x, and when that's the case we use a process called implicit differentiation. And we can find, our goal is still to find our dy dx, in other words the slope of the tangent line to y as a function of x, and in some cases as a function of x and y and or just y. So nevertheless, the process is a process that involves 4 steps, the first step being to differentiate each side with respect to x. And so starting with problem number 9, differentiating each side with respect to x, we see that we have the derivative on the left-hand side, the derivative of x squared y with respect to x, plus the derivative of xy squared with respect to x, equaling the derivative of 6 with respect to x, and that's just 0. Okay? And so, taking the derivative then of x squared y, we have the derivative of a product, and so the derivative of the product is the first times the derivative of the second, and the derivative of y is just y prime, or dy dx, plus the second function, which is y, multiplied by the derivative of the first, which is 2x. The derivative of x squared is 2x. And so that right there, this guy right here, represents the derivative of x squared y. So that's the first part. Okay? And then we add to that the derivative of xy squared. And so we can see we have the derivative of another product. Product being the first function, which is x, multiplied by the second function, which is y squared. So the derivative of the product, again, is the first, I should say, multiplied by the derivative of the second. Now, the derivative of y squared we should know to be 2y y prime. We have to use the chain rule because that's not just x. Okay? Plus the derivative, plus the second function, which is y squared, multiplied by the derivative of the first, and the derivative of x is 1. And so we get one big long expression here on the left side equaling 0. And by the way, the second part here, these third and fourth terms, represent the derivative of x y squared with respect to x. Okay, well, the second step says to gather all the terms on one side that have a y prime in them. And so we see that we have x squared y prime plus 2xy y prime, okay, equaling, now we're going to do this, since we're running out of room on this particular slide, we're going to do this a little bit of work in our heads here. We're going to be subtracting our y, actually our 2xy. So this right here is 2xy, if we write it in order, and over here we have our y squared. So we're going to be subtracting 2xy, and also we're going to be subtracting y squared from both sides of this equation, minus 2xy and minus y squared. Okay, so in doing that, we end up getting on the right side negative y squared minus, I should probably write it in the right order, negative 2xy minus y squared. Okay, and then it says step 3 is to just go ahead and factor. This is all algebra 1 now. We're just factoring out the y prime, and what we're left with is x squared plus 2xy equaling the right side. Okay, and then we're just going to go ahead and divide both sides by our x squared plus 2xy. And when we divide both sides by our x squared plus 2xy, we have, well, there's not enough room here to write it again, so I'll just put a box around it. That's our answer for y prime. So you see, y prime equals this, and that's our dy dx. dy dx depends not just on x, but also on y. So that's our number 9. Let's see if we can get number 10 in here before the end of this video. Okay, so same thing, going through the same steps. We're going to differentiate both sides. Again, our goal is to find dy dx. Okay, and we can see that y is not explicitly defined in terms of x, and so we're just going to differentiate both sides with respect to x. And the derivative of the left side is the derivative of x cubed, which is 3x squared, plus the derivative of y cubed. Now, the derivative of y cubed with respect to x, that is not just x, and so we have to use the chain rule. 3y squared times y prime. Okay, equaling 18 times. Now let's do this. Let's say let's write it like this so it's maybe a little bit easier to understand. 18 times the derivative of this. That's the constant multiple rule. If you take the derivative of a constant times some function or some variables that will change depending on x, then we can multiply that by, we can write that as 18 multiplied by, I should say, the derivative of xy. Okay? And so that's similar to if we, the derivative of 2x cubed, we can write that as 2 times the derivative of x cubed. So that would be 2 times 3x squared, and then we can multiply the 2 times the 3 at the end. Okay, so similar to doing something like that, sometimes it's easier when we have the constant times the derivative of a product to just take that constant out first, and then we can deal with the constant later. Okay, well, let's go ahead and just rewrite the left side, and then we'll focus on taking the derivative of the right. So we have 18 times, now the derivative of the product, again, you should be getting pretty good at this, we've done this a few times. The derivative of the product is the first times the derivative of the second, plus the second times the derivative of the first. And we see on the right side we can multiply out now the 18. We can distribute the 18 to both terms, so we have 18xy prime plus 18 times y. Now we can see we have a couple terms, now they're on opposite sides of the equal sign, that have a y prime in them. And so what we're going to do is we're going to subtract 18xy from both sides, 18xy prime. Okay. We're also going to be subtracting 3x squared from both sides, because what we want to do here again is we want to bring all the terms to one side that have a y prime in them and move all the other terms that don't have a y prime in them to the other side. So we have 3y prime minus 18y prime equaling, what do we have, 18y minus 3x squared. At this point, I'm not enjoying rewriting this number every single time, so I'm going to just divide every term by 3, and we can divide that out at least, make it a little simpler. So we get, at the same time though, I'm going to go ahead and factor out that y prime from the left side. Maybe I shouldn't do that all at once, so I won't. Y squared times y prime minus 6 times y prime equaling 6y minus x squared. So the third step is always just to go ahead and factor out that y prime, because that's what we're solving for. And when we factor out the y prime, we can see we have a y squared minus 6. And if we divide both sides, let's do that in red, divide both sides by a y squared minus 6, we end up getting y prime by itself, which is our ultimate goal. Again, is canceling those guys, putting a box around what's left, and that's our y prime. Y prime equals that stuff. Alright, so that's 9 minutes. Maybe I should make a second video for the next part. Nah, I'll go ahead and try to squeeze it in here. I think we can do this in under 15 minutes. Number 11, we can see the relationship between x and y. Y is not by itself. It's not explicitly defined in terms of x. And so we're going to take the derivative of both sides with respect to x. That gives us, on the left side, the derivative of y squared is 2y times y prime, equaling the derivative of the quotient. That's the low d high. There's the low d high minus the high d low over low squared, x plus 1 squared. Now, just to make sure it's clear, the low is the denominator, so low, and the derivative d high, meaning the derivative of the numerator. Derivative of x minus 1 is 1. So maybe I should put that up here. The derivative of x minus 1 with respect to x is 1. That's where that 1 comes from. Okay. Well, this one comes from the derivative of, remember, we had high d low. So the derivative of low, which is the derivative of x plus 1, is also 1. So that's where that 1 comes from there. And then divided by low squared. So we really have very little to do here, although I'm seeing that we might be able to cancel some things. So let's get rid of the parentheses in the numerator. X plus 1 minus x plus 1 all over x plus 1 squared. So that's kind of nice, equaling the x's cancel, and so we just get 2 in the numerator, 2 over x plus 1 squared. So now if I divide both sides or multiply both sides by 1 over 2y, 1 over 2y, then these 2y's cancel here, and what we end up getting, I have enough room to write it down here, y prime equals, 2's are going to cancel, and we get 1 over y times x plus 1 squared. So I was able to fit that in. We'll catch you in the next video.